today we take an important step. We talk about the three fundamental data structures which are required for all your programming. Some of you would already know in other language or even in Java. These three are very crucial and we need to know them very well. And the only way to get to know them is to use them. So what are the three? One is called list, which is a list of data, which is nothing but internally either a linked list or an array, which is made to appear like a list. You can make an array appear like a list, you know that. Or it is a linked list internally, so it's a list. So that is one data structure. Then the second data structure is called a set. I think all of you know what is a set. Set is, if you ask in one or two lines, set is an unordered grouping of elements. When I say unordered, what does it mean? If you compare it with a list, to a list you can ask, get me the first element, get me the fourth element, get me the eighth element. To a set, you can't ask, get me the first, get me the second. So what is the good property a set has? It is unordered, but it has a good property. What is that? It doesn't allow duplicates. So if you try to add two identical elements to a set, it will reject the second one. And if you keep blindly adding elements to a set, no problem. It will retain only the unique ones because it will not allow duplicates to be added. So whenever you are looking for non-repeating or unique elements, set is an excellent idea. So we have the set, we have the list, and then we have the map. Map is also called dictionary in other languages. So what is a map? Map is a mapping or a dictionary where you have key on one side and value on the other side. So it's a combination of, or it's a collection of key value pairs. Now key can be anything, value can be anything. You have to declare a priori beforehand what should be your key and what should be your value. For example, your key can be integer, value can be string, or key can be string, value can be integer, or both can be integer, or both can be string, could be anything. Okay? So any kind of user defined object you can have as your map. Now all these three people, set, list and map, what Java has done very cleverly and intelligently is right from the beginning they said we are not going to define what is a set, what is a list, what is a map. Instead we are going to create them as interfaces because we know that over time as Java evolves the implementations may change. So let us not rigidly define the implementations in the beginning. Let us just define what we expect from a map, what we expect from a set, what we expect from a list. So all these three gentlemen, list, map and set, they have been implemented or they have been created as interfaces. What is the beauty of that? If you create them as interfaces, tomorrow you can assign them, interface reference as you know from Java, can be assigned to any implementation. So you can, today you may have some implementations, tomorrow somebody smart as the language evolves may come up with other implementations, we can still use them because we have not said these are implementations, these are interfaces. Using that interface, I can refer to any implementation. That is the beauty of creating interface and implementation. So these are all interfaces. And mastery over these three is fundamental to you doing anything else in programming. If you don't know how to make set dance in your hands or a map or a list, you won't do much in programming in any language. If you don't know these data structures intimately, we can't do much. Okay, so we'll try and learn this properly, and the only way to learn is by creating examples, situations, and assimilating them. Okay? So we will start with map, not for any particular reason, but because map is more popular than list, then set. Or map, set, and list. It is not in any particular order. It's just that we choose to learn it in that order. So what is a map? I told you, map is like a dictionary used to store key and value. So we will start with creating a map, then I'll do an example, and then you will do an example, and let's see whether some of you are able to do or not. So we will start with using a map. Here is how you would create a map. So you would say map, then you would put these angular brackets which are called generics. This generic will have two parts, one part for the key and one part for the value. So suppose I want string as my key, I'll say string, and if the value has to be integer, I have to say integer. So this is a map interface which has its key. So first thing in the angular bracket, we say this is the data type of the key. This is the data type of the key. And this is the data type of the value. Okay, data type of value. So we start with that. So before we design a map, we should be fundamentally clear in our mind that what is the kind of key I am seeking, what is the kind of value I am seeking. Now, just because we are on this point, this can be an object, any Java object or Java class. This can be another Java class. Anything is allowed. Any key is allowed, any value is allowed. That is the beauty. Now, you can't say int. You have to say integer. This is a wrapper class. Because int is a primitive, integer is the wrapper. That is the object equivalent of int. Now, all these interfaces work only with objects. They don't work with primitives. You can't use int, long, float. You have to use their wrappers. That is one care you have to keep in mind. So you can say this is an interface, M, and you can say M is equal to, now, okay, let me write it again on another line. Okay, let me write it here. So map string comma integer M is equal to, now I can say one of these implementations, new hash map. This is one kind of map, and just put angular bracket. This is corresponding to this. Again, if you want, you can say the same generic type, string and integer, but that's not necessary. So you can say new hash map, and because you are creating an object, a lot of people get confused with this. This is for the generic type. Okay. If you are getting confused with this, you say new hash map, string, integer, same type, but not necessary, because Java is smart enough to know what is on the left hand side and use the same thing on the right hand side. So if you are fond of typing, you can put it again here, string and integer, but not necessary. And this is because you are creating an object of this type, so you can say hash map. Now hash map is typically very fast because it is based on hashing algorithms and hash code is used of the key. If you don't like hash map and for some reason you want the data to be sorted on the key, then you should not use a hash map. Then you can say new tree map. Okay? This is a sorted thing. So unless you need it, don't use it, because this is slow. Okay? And this is fast. So as long as you don't need sorting on the key, don't use tree map, use hash map. Okay? There are other kinds of maps, but almost always you will use either a hash map or a tree map. Now, there was in old Java, because sometimes you will see code which has been written many years ago, there will be something called hash table. Okay? Hash table is an earlier avatar of hash map. So it is used in old code and it did not support key value. Okay, so anything could get in, and that was a problem. Now hash map also had an older version where you didn't have to say what kind of key you are going to have, what kind of value you are going to have, but that version suffered from problems because sometimes you would store entries with strings as keys, sometimes with some other object as keys, and you won't know, it won't give you an error, compilation error. And generally programmers found that very irritating, very difficult, and because as far as Java is concerned, you'd like to get a lot of compilation errors, because the beauty of Java is during compilation itself most of the things get ironed out. So if you have got your program to compile, then more or less you have got a lot of logic right. Not necessarily, but the compiler itself is smart and strict, so it encourages you to follow more discipline, unlike C++ or any other language, including Python. Python is very liberal when you are writing the code. So sometimes you get wrong data types in. Java is very strict. For example, in this situation, Java will always have key as string and value as integer. If you try to put some other value, it will immediately give you an error. It will say, no, I can't accept it because I need the key always to be a string and the value always to be a integer. Okay? Now, the best way to understand hash map is two steps. First is, we'll look at the documentation, look at the methods which typically are used for creating a hash map. We'll just look at the methods for a few minutes, and then we will take a small application and create a hash map which will hopefully help you understand. After that, you will create an application and let's see whether you can do it. Okay? So we will just go to Google and see hash map documentation from Java 8. So this is the map, because whatever methods are there in map will work. Can we make it little bigger? Okay, you can see how many classes are implementing it. Can you come down? So you see I'm not going to go through any class in detail. These are all the classes which are implementing the hash map. Okay? Which are implementing the map interface. So many already there. They are each used differently for different purposes. Now, among them you will find there is a class called properties, right? Some people call it properties because it's key value. They prefer that. Some people use linked hash map because if they want to preserve the order, then there is something called, as I mentioned, hash table, and concurrent hash map. There are somebody calls this by name attributes, because people who are coming from JavaScript kind of background, they are familiar with the JSON kind of format. So if you are thinking JSON, JavaScript object notation, then you will think in terms of attributes, key value as attributes. So if you are comfortable with that, then you can use an attribute class, same interface, but the class will be new attributes, like that we will say. Okay, so there are many manifestations with small differences, but the most popular by miles is hash map, and the next most popular is tree map. So from a teaching point of view, obviously we can't teach all the things. We generally teach only hash map and tree map. So for most applications where map is required, hash map is good enough. For some applications where sorting is required, tree map is required. So by default, people use hash map when they say map, and sometimes they use tree map. Okay. Now what are the popular methods in a map? Now we are looking at Java 8 because some methods have been added. So I'll briefly go through the critical methods, not all the methods that not used. So one of the method which is used is clear. Now you would understand what a clear would do to a map, to a dictionary. It would clear all the entries from the map. It would make it empty. Okay. Then compute, no, I never use compute, so I don't think you will need compute. This is very popular. Contains key. That means there is a dictionary in which you are checking whether a particular key is existing on the key side of the map. The map has a key side and a value side. So on the key side, does a particular value exist or not? Whether an entry for this key exists or not. That is what you do with contains key. Now contains key's counterpart is contains value. Does that value exist on the right side? Contains value is not used often because normally you do retrieval based on key, not by value, but it is there. Then entry set produces a set of what? Set of all the entries. If you want to go through the entries in the map one by one, sometimes you will need them, especially after you have done some operation, you want to go through all the entries at one shot. So we will write a loop in which you will go through all the entries one by one, retrieve them and deal with them. So that is entry set. Equals is just to check whether a map is equal to another map. For each is rarely used. The two methods which are used very often are get and the new one which is called get or default. Now I'll spend a little while explaining the difference. Get is what? Given a key. So normally in olden days, 4 or 5 years ago that is called olden days. So in olden days, what we used to do? First we used to check whether the key exists or not. Okay? We used to find out whether the key exists in the hash map or not. If the key exists, we would say get on that key and then the associated value will come. So get will give the value associated with the key. That was the original model of interaction. I'll repeat this, please follow. In olden days, we would first say contains, ask whether this key is already existing in the table. If it is existing, then we would say get. Okay. So nowadays you see modern code doesn't do this checking for checking for contains key and then get. That is how older people used to write code. Nowadays modern programmers Java doesn't use that way. What they do is they use the alternate method, get or default, which is like saying, if the key is there, get me the value or get me a default value, which is 0. Okay? Normally it is 0, it could be anything. So they don't do this contains and get. Nobody writes it. If you are seeing that code has been written 4 or 5 years ago. All new code will use get or default, which serves the same purpose. If it is not there, get some default value. So if I get the default value, what does it mean? That means that key is not there. So instead of writing an if and code like that, nowadays they write it in one line. Nobody writes these 3 lines or 4 lines of code. So get or default, please get used to get or default, because that's how you will write. Either the key is there, if it is not there. If the key is there, the value comes out. If the key is not there, the default value comes out. Okay? So normally it comes in very handy, and that's why this was added in Java. Can we just click on that? I don't know whether it was added in 7 or 8. It was added in 8. 1.8 means 8. Okay? So it's a recent means again 6-7 years have elapsed. Okay. And nowadays we see it used often. So these are very important methods, get and get or default. Hash code is just to find out what is the hash code of the map, not used often. Is empty is used, definitely. Empty is to check, are there any entries in the hash map at all or not, right? Is there anything at all in the hash map or is it empty? So after you do a clear, is empty will return true, because there won't be anything there. Then key set, also useful method. What it will do? It will give you a set of all the keys. So if you want all the keys in one shot, you want it, you'll get keys, key set. So that is the use of the key set method. Now, merge is a new method which is introduced to merge sometimes two maps together. One map has some key values, another map has some key values. You want to merge them, and while merging what you want to do, there may be conflict. Okay, maybe I should just give you a picture. Suppose you have one hash map and another hash map. In both the hash maps, there is a key, let's say A. Key is a string A or character A. A exists here also, here also. Are you getting the picture? Now, when you merge these hash maps, what should happen? Should this value stay or should this value stay? If there is no conflict, there is no problem. It will straight away merge. But if there is a conflict means the value exists here in the first map also and the value exists in the second map also. So what should we do? So there is a collision resolution function that gets called, or collision resolution procedure or method which gets called. What does that method do? It checks what are the values. You may say the higher of the two values should become the new value, or the lower of the two values should become the value. All that is called collision resolution or conflict resolution. So you can describe what collision resolution. So that is a merge. So can you see a parameter there? I will show you how to do merge adequately. But can you see a function there called bifunction? Bifunction means a function which takes two parameters. It's called a bifunction. This is all new Java. They have introduced all this functional programming. I told you, lambdas and functional programming and all that. This is all the new Java, not the old Java. So there, this is, by the way, this is also a new method introduced, I think, in 8 or later. So there is this remapping function. When was it introduced? Yeah, it's a Java 8 feature. Okay, so going back. Now there is that remapping function. Can you see that parameter remapping function? That is a method which gets called, it's a lambda function, so which gets called with two values, which says how should I resolve the conflict. It will be passed both the values. Okay. Then the other very important method is put. It's the reverse of get. So when you want to put a new value or update a value, now put, you have to understand, if the key already exists, the value is overwritten. I am repeating again, you will see this in examples also. Put, if the key exists already in the map, then the value gets overwritten. If it doesn't exist, if the key doesn't exist, it's a first time entry. Did you understand? Put updates the hash map. It has two behaviors. If the key already exists, then this value overrides that value, whatever you are supplying now. The last put will override earlier values. If the value doesn't exist, obviously a new entry is created in the map with key and value. This is the way entries are created. So there is nowadays another, we never use put all. Now a new version of put has been created. Put only if absent. If the earlier put used to do what? Update the value. Are you understanding? Put used to update the value. It still updates the value. But I want to update the value, or I want to make an entry if it is not there only. I don't want to overwrite. So if I want to do that, I will say put if absent. So if the key is not there, then only it will come in. Otherwise it will not. Are you understanding the difference between the put and the put if absent? Put will override the value if the key already exists. Put if absent will not make a new entry if the key already is there. It will not make a new entry or update the entry. Okay. So this is also a new addition. If you want, you can check. It's a Java 8 edition. You should be aware, because sometimes if you are working with older versions, these things cannot be used. Okay. So these are all enhancements which are happening over time. So put if absent, remove. Remove, you know what is remove. Remove is also used often. Remove is just get rid of that entry given the key. Then remove object value anyway. replace not used much. Size is used. What does size give you? How many entries are there in the map? That is size. Okay. In the map, how many entries are there? Then values will give you not a set, but it will give you a list of all the values, a collection of all the values, right? Just like key set will give you set of keys, values will give right side. Okay. But it will not give you as a set because values may repeat. Keys will not repeat. Values is given as a list because list can contain duplicates. Right? And values can be duplicate. For the same key, for two different keys, you may have same value, no problem. Okay, so these are the things, these are the methods which are available, and the way to understand a map is we will create an application, very common application, and we'll create it in front of you, and please watch and please create with us so that you get comfortable with a map. So almost all applications need map. You cannot write an application. I will say that if you do 10 applications in Java, 10 small applications also, 8 of them will have map. Okay? So that's why map is a crucial data structure, because how else will you maintain key values in solving any problem? Okay? So let's take a small problem. Okay? Let's say I have been given a paragraph, just a paragraph in English, or a sentence or a bigger sentence in English. I want to know the frequency count of words, because maybe later I want to convert this into a bar chart or something which shows a histogram of words. You know what is a histogram, right? Frequency of how often a word occurs, right? So we basically want to do this. Of course, we are not building the chart yet. You can easily create a chart in Java, but we are not doing that. We are just building something very simple. It's a frequency counter. That is, each word has occurred how many times? Are you with me? So we'll write a sentence and we will just write a frequency counter to do that. So we'll read the sentence from the user, then build a frequency counter. Are you clear? Yes? So let's start. We will start class test. We are starting to write. Please, what is this called? Lab what?
Practice 1.
Practice 1 of today.
Today's date.
What is today's date?
5th.
5th July. That's the date? Okay. 5th July 1st. Practice 1. Okay. Then I'll give you an exercise. So hopefully you'll be able to do. Okay. Watch this carefully. So I'm creating a scanner. You know why. Now I'll read a whole line or a whole sentence. You know what to do. I'll do a next line to read a sentence, and I'll build a frequency counter for that. So, okay, we are reading a sentence. Now what is the first thing we ought to do? What should we do? Create? Create hash map. We'll create a hash map for sure. Okay, we'll follow him and create a hash map. Then we'll do the next. Then I'll ask you what we should do next. So how do we create a map? See this. Okay. Now, wait, Bob. What should our map look like? What should be the type of the key and what should be the type of the value? Key should be of type string, because we want a word frequency counter. So word is a string. So key is a string. Value? Integer. Because against every word, what are we trying to record? How many times that word occurs in the sentence. Correct? So it's a int. We can't say int. Remember in these data structures, we have to use their wrappers. So we say integer. Right? So here we go. Map string, comma, integer, and there we say MP, whatever you want to call it, MP, or frequency counter, F count, Okay, okay, is equal to new. Now, here I have to say whether I want a hash map or a tree map. What do you think will work? I don't want the words to be displayed in any sorted order. If that is not a requirement, then I don't need a tree map. Please remember, tree map slows out things because every time you have to sort the data on the key. Every time you add, every time you do a put, you have to sort. Yes, no? So please don't use tree map just because it gives sort. All data structures from now on, please think. They all come with certain comfort and they come with certain cost. More the comfort, more the cost. Cost means you think money is going. No, performance. Okay? And especially as you become more specialized, it is not just important to write correct code, it's important to write optimized code. Very, very carefully you have to think about what that line is going to do and why am I writing this line? Because that is what they will question. In any interview, they will first ask, why did you do this? Okay, now map string integer, new hash map. Achha, if you want, as I said, you can say string and integer if you want in that angular bracket on the right side. But if you don't want, that's fine because you just say angular bracket and it will work. Why it will work? Because that left side will tell what the right side should be. And then I have that open bracket, close bracket. That is just because I am creating an object, right? So I have created a hash map and now what am I going to do? Okay, now comes the next step. What should I do? I have read a line, I have read a sentence. What should I do? Sorry? It's already a string. I have a big string. Traverse? No. Before traverse? Split. That was what I was looking for. You have to first split the string, chop the string into pieces so that each word can be stored along with its count. Yes? No? Okay. So, what will we do? How do we chop? Split. So, we will say split on the string and what will split give me? What will it give me? Array of strings which are split from the original. Correct? So, we will say string SARR, call it SARR, equal to string dot split, that is your s dot split. Remember, split needs a delimiter. Yeah. In our case, the delimiter can be a blank space, blank, or you can even give a regular expression as a delimiter. Okay. So, or just a split will also work because the default delimiter is space. If you want comma, then you have to give comma. If you want colon, if you want the bang, you have to give all those delimiters in the brackets, in that string, quoted string. So I have managed to split the string into words. So those words are sitting in SARR. Okay? Now, what should I do? What should I do now? I should go through each word, check whether this word is already there in the dictionary. Okay. If the word is already there in the dictionary, then I should add to the value. If it is not there in the dictionary, then I should create a default value of 1. Yes? Is that correct or not? If the word is already there, whatever the frequency count, I have to increment it. If it is not there, I should create it with the frequency count of 1 because it's the first time it has appeared. Right? How will I do that? So, I will first write a loop, okay, for each string or for each word. S again. For each word in SARR, For each word in SARR, what will I check? Is the word there or not? Now, remember, in olden days, we would use contains, this word. Now what will we say? Okay, you want to look at the method again? Okay, look at the method. So, we would earlier use contains and then get. Now we will say get or default. If it is there, it should give us whatever value is sitting in that, against that key. If it is not there, it should give us a 0. So the default value should be 0. Then I can add 1 and put it back. So that's a very simple code. You will see I'll write the code in 2 lines. Okay, go down. Yeah, so I'll say for each word, okay, now I'm going to get the original count. So say O count, int O count is equal to, I'm getting the old count of this word. Okay, because this word has occurred again. I'm getting the old count of this word. I'll say f count dot get or default, get or default. What should we say get or default? On word, comma 0. Okay, now I am hoping you will understand. Anybody understood? What are we trying to do here? We are saying f count dot get or default, that is in the map, look for the word, look for the key word. If you find it, whatever the value associated with it, give it to me. If you don't find it, give me 0. Once again, look in the map. So line 9 says, look for word in the map, look in the key. Do you find this word in the key, any of the keys? If you find it, give me the value associated with it. If you don't find it, give me 0. First time what will happen? First time what will it give? It will give a 0, no? Obviously it won't find it. Because it won't find it, it will give me a 0. That's what I want. Because if a word does not exist in the dictionary as yet, this is the first time the word is occurring in the sentence. Yes? If this word is occurring first time in the sentence, it won't be there in my dictionary. So if it is not there in the dictionary, it should give me a 0. So I'll get a 0. Then what I'll do? I'll just do one line. So either it will give me a 0 or it will give me whatever number of times the word has already occurred. That is called the old count. Now, can you tell me what will be my next line? F count dot put key O count plus 1. Beautiful. So we'll say F count is the map, right? Dot put what? Again I am updating it now. Put, I told you, updates it. If it is not there, it updates it. So key is what? What is the key? The word is the key. Word, comma, O count plus 1. As somebody pointed out, it should be O count. If it was 0, then it becomes 1. If it was already there for some time, then we will get the entries. Okay, that's it. Now, then we'll print SOP on the map, on the F count. Let's see what we get. Our toString is implemented on all these data structures. Println, F count. So we'll just run it and see. Okay, we have an error. S dot split. I think you have to give an argument which is space. I think it is not taking default. Yeah. and you have to import java.util please for all these classes. Now we'll give a sentence. I'll give the sentence. You recognize where is it from. Okay, it's a very famous sentence. You recognize, let's see how many of you have anything in your head besides something else. Okay. 2 2, just say 2, space, 2, space, B, or not 2 B is the question. Is the question. Now we'll enter. Let's see what we get. Okay. Okay. So if you see the answer, you see the word 2. Can you see that? It has given how many times each word has occurred. We have just printed the hash map f count, and it is showing us that 2 has occurred 4 times, B has occurred 2 times, and the rest of the words have occurred only once. These are all the entries in your f count or in your hash map. These are the entries which were created in the hash map. Now, do you get a little more understanding of what the hash map is? Now, had I used a tree map instead of a hash map, the keys would come out in a sorted order. Right now, the keys are coming in whatever order. It is a hash code, random order. There is no particular order in which the keys are coming out. But if you want the keys to emerge in a specific order, in a particular order, then compulsorily you will have to use the tree map. How easy or how difficult it is to change our code? Just one line, not even one line, a little bit of change. So we, instead of creating a hash map on line 6, we just say we'll create a tree map. But don't do it just like that for fun. Okay, it's slow. So tree map will give in sorted order of keys. That's all. So now you see your answer will change. It will be in ascending order of keys. That is the words. Words are the keys here. Yeah. Again, we'll give the same sentence. 2 B or not 2 B is the question. Yeah. So this is what we are doing, and if you enter return, yeah, now you can see the data is in ascending order of the keys. Can you see that? No, yes. It's in ascending order of the keys because we used tree map which sorted the keys while adding them. It will always maintain this in sorting. What it means though is that every time you enter data, it will have to keep it sorted, and that's why the cost is there, right? It will be slow. But if your problem needs it, you use it, not otherwise. Okay, so this is what a map can be used for. Now, let's see, generally I have seen most people, if I give one example of how to use a map, create a map and how to use it, people are generally able to use it, okay, in the earlier batches. Now let's see how you can use it. How you can create a map and use it. So I am going to give you an example. Okay, just a minute, we'll give you. Okay, the question is like this. Let me also try and understand the question. There are 2 friends playing a game. Rule of the game is to get desired brands with the list of available quantities. So these are all different brands. The brand quantity should not be used twice for the count, and available quantities are providing exactly one possibility. Okay, what it means is, in simple words, this is what it is. So you are given an array of integers. This is your array of integers. Now, the answer is, you want to build a number 9. So here is the thing. You are given a series of numbers. Think of it like this. You are asked to build a number 9 and say what is it, which of these two numbers, we want the indices of the two numbers which will produce this 9. Yeah, so the value should come to 9. So the numbers are 2, 7, 11, 15. Now, if they are 2, 7, 11, 15 and the desired sum is 9. Now, you can use the number only once. So, you have to get 9 and the question is, how would you get 9? So, the 9 can come through a combination of indices 0 and 1. Okay, 0 and 1. So, you have to print the indices of the numbers. Okay, do you have any other example? Okay, so here it is. Now look at this. The numbers given are 2, 7, 11 and the number that we are building is 7. This is the target we have to build, 7. So how can we build it? The answer in this case should be, okay, so here is another example. So enter number of brands. These are the 4 quantities. So first he will give the number and then he will give the quantities you have to enter. You have to read that in, put it in an integer array. Now for 7, if you have to build 7, you have to take 2 and 5. Okay. So indices are 0 and 3. Okay. Now, since it's the first time we are doing it, this is going to be used using a map. Okay. So what will you do first? I mean, I'm just giving you a clue. You have to do it using a map. There are other ways of doing it, but they are all slow. You have to do it using a map. Map is of int and int. So you will say first time you will get 2. I'm talking about this question. So you will get 2 and you will keep the index of 2 as 0. Then you will get 7, keep the index as 1 because you can't lose the indices. 11 and you should not search it again. Index is 1, index is 2 and 15 index is 3. And the value that you want to build is 9. So now, okay, you will go through 9, you will go through the first key, you will go through the first key. Now, you have built this, you have kept the indices, now you will build this and now you will take 2, if 2 can be built. Acha, the answer, there is only one answer, is it? So you have to print that answer and you are done. There is only one answer. So you will take 2 and then you will see in the map, if I am working with 2, what should be the other value? 9 minus 2 should be 7. Does 7 exist in the map? Yes, it exists. So you have to get the value associated with it. If it exists, value associated with it is 1. So the answer then is 0, 1. Now if you don't get that, you have to proceed. Now here 2, 7, 11 and 5 again will be stored in the map. Again you try with 2. In this case you are getting with the first one only, but it may not happen. So 2, now you again search in the map for, here the value should be 7. So you should search for the value 5. That is 7 minus whatever the key you are looking at right now. This, you have to go through this array again and check whether it is 5 is there. 5 will be there, you will take the index associated with 5 and display it. If it is not there, we'll go to the next entry. So anyway, I think we are making a mountain of a molehill. So I will repeat it again. So you are given a bunch of values. So value 1, value 2, value 3. These are all there in your array. So what you have to do is, against the value, you have to store what are the indices at which it appears. So against V1 you have to store 0, V2 you have to store 1, index, V3, this is 0 index, 1, 2, this is 2, V4 is 3, and let's say I give a value X. So first we'll check with V1, is X minus V1 there in this key? If it is there, we get the index and we are done. If it is not there, we proceed to the next value and V2. And V2, then I say, is X minus V2 there? And then what is the index at which it is there? Like that. So the data may not be in any ascending order, descending order or anything. So that's how you have to do. Now please use a map and do it. It's a map exercise, so please do it with a map. Okay. It becomes easier to solve with a map. Okay. And as soon as you are done, let us know. Some of you will finish very fast. So you have to maintain a map of integer and integer. So the key is the value which you are getting from the array, and the value is the index. Index of that element. Because finally what you have to display are the indices of the two elements which make up that target sum. That target sum is given to you. So try to write the code. Yeah, somebody finished. Okay, there is another person. Okay, I hope all of them have used map. We'll look at it. Please use map. Key value. Learn to do. Documentation is there. You have to print indices. Otherwise you will keep writing a very slow solution. Every time checking. Loops. One loop should only be there. No, two loops. One to add to the map and one to go through the numbers. Yes. Only two for loops. There should not be a nested for loop in your answer. It should be two for loops. If you have used a map correctly, there should be only two independent for loops, not one within the other. Because then you are not using the map correctly. So about 22 people finished. Take one of the first ones. Okay, let's see. Okay, doesn't matter. Any one of the first is fine. Yeah. Okay, let's see how it goes. Go up. Okay. I have not seen the question. We will analyze the answer. One of you has done it correctly in the first shot. So let's see whether it's optimal and a correct solution. Can we make it little bigger? Little more bigger. Very good. So we create the scanner, enter number of brands. We get n. SC is equal to next int. So that gives us the number of numbers which are going, the bigger size of the array. Then using that, line 35 very correctly is creating the array, new int n, very good. Then it's a hash map of integer. So hash map is also good on line 36. Then enter quantity, each quantity, n. He is reading all that quantity and very nicely putting that quantity and the index in the hash map. That line 40 is beautifully done. In fact, the whole loop 38 to 41 is very good. For I equal to 0, I less than n, I plus plus. He reads one number at one shot, and when the number is read, that number is blindly put in the array, assuming that number occurs only once. That is a fair assumption. If not, you have to check and then put, doesn't matter. So the number is put in the array along with the index. So the hash map is built up. So at the, we have the number and its corresponding index. Now he goes through the desired count, enter the desired count, and answer is always a couple. So he's created that answer also well, line 44. But you can print one space other also, no problem. New into, and then now can we scroll up a bit? Scroll up. Now comes the important loop on line 46. That is where the real stuff happens. For int, he is going through the array again. For int I equal to 0, I less than n, hm. Now see that line is very good. hm dot get d minus arri not equal to null. I forgot to say this, but I think this person got it. If get is empty, if the get, that value doesn't exist, it will return a null. Okay? If get, that is get without default. If it is default, it will return that value. But if you just use get, it will give null. There are many ways of writing that, but this is very nice. Look at that if statement. So if hm dot, I am on line 47. If hm dot get d minus arri, arri is our number, d is our target, he is looking for target minus this number for the pair. Remember, we have to find the pair. So d minus arri, if it is already there, and if it is there, then you will get the index associated with it. If it is not equal to null, then answer 0 is equal to I, that is the first of index of the pair, and the second is ans1 is equal to hm dot get d minus arri. Okay, and then k, I don't know what he is using k for. Okay, whatever. I don't think k has a purpose because k doesn't seem to be getting tested either. So that's okay. So k is not needed there, I guess. And as soon as you get the answer, you break because you are done. And you print math.min, okay, the lesser of the two is printing and the more of the two is printing. I think yes, we expect the data to be printed in the ascending order. So he is doing that less and more very nicely. Okay. Very good code. Okay. Let's see one more. Okay. Somebody else's code. I'm just seeing how this looks. Okay. Enter number of brands, get the int, create the array, read the values, get the desired count. Now start creating map. For integer x, arr, k starts at 0. So he is putting the map one after another, the value, see that line 45, m dot put the key, the value of the number, and against that the index, k is the index, so it gets incremented every time. Then again second iteration, line 47, I equal to 0, I less than n, I plus plus, x is equal to arr I. Then checking whether m dot contains key c minus x, the other side, is it there or not? C minus x should be there. So if it is there, then very nicely, this is nice code, I plus space plus m get c minus x. C minus x will give you, with that key, whatever is the index. So it will get the indexes of both the numbers. Again, good code. Who is this? Somebody there. Okay. This is good code. Yeah. We will look at one more. Yeah. Let's see how this goes. Okay. So enter number of brands, next int, quantity, hash map, reading all the data. Now look at that line 37 to 39. I equal to 0, I less than n, I plus plus. Reading every integer, putting that key and its index in the array, in the hash map, t and I. T is the value, t is the key, that is the value in the array, and its corresponding index is I. Then reading the count and then going through the key set. Oh, very good. So this time this person is going through the key set, which will give you the keys. So go through all the keys in the key set and check whether T is equal to C minus I, that is the corresponding value. If it is there in the map, if that value exists in the map, wonderful. If it exists, get I, get T. Get the indexes of I and get the indexes of T. Get both the indexes and good. Who is this? Good code. Nice code. So now we have time, so we will do what is called as a set. Anyway, I am going to repeat each day one of these, okay? Each one of these, hopefully. Today we will do hopefully map and set. Later we will pick up speed. I will not leave till we have done at least 4 or 5 on each, okay? Because till then you wouldn't have understood what to do. You have to be very comfortable with these 3 data structures. They are mother, father data structures, whichever language you do, whether you are writing Python or Java or C++, all these are there everywhere. Only names change. In Python, they will become dictionary, list and set. In C++, they will become map, vector and set. Okay. So the names will change little bit, use will remain same, and this is what will be tested heavily in any interview or test. Okay. Okay. So let's start with a set. Now first I'll describe what is a set, and then we'll do a quick example of how to use a set. Okay. So what is a set? Set is also a grouping. It is not key value. What is it? It has only, it is unordered first, no ordering, no first, no second, no third. It is a grouping of elements which does not allow duplicates. If you try to add a duplicate value to a set, it will give a false. Return value will be false. Okay? So how do let's look at the documentation of a set. Set also, there are 2 implementations. One is called a tree set, which will give you sorted data. Second is called hash set. Just like you have hash map, you have hash set. And just like you have tree map, you have tree set. So if you want data to come out in a sorted order, use tree set. If you don't want data to be in any sorted order, you want it to be fast, use hash set. Okay? And again, set is implemented as an interface. So this is the set, and its implementations you can see. One is hash set, which is very popular. Okay, you can see there hash set, and the other popular implementation is tree set. There are others also, but we don't use them often, so we don't talk about them. You will never be tested also on, in any competitive exam also, on either tree set or hash set. Other than tree set or hash set. Other than that, you will never be asked anything else at this stage. Okay, what are the methods on a set interface? Come down. Okay, the methods are adding. We don't have put, we have add. Okay, add an element to a set. Okay, then add all is used to add a complete list or a set to another set. Clear, you know what clear does? What does clear do? Make the set empty. Then you have contains, whether a particular element is there in the set or not, that is contains. Same value as you check for keys in a hash map. So you have contains element. Then contains all, if you want to see whether a complete set is there as a subset of another set. Equals, checking whether 2 sets are equal. Is empty, checks whether it's empty or not. Iterator we never use. Remove, removes element. Remove all is like a subtraction. Retain all is like an intersection. We will see this when we need them. Size is size of the set. Split iterator, we never use it. Converting it into an array, we don't use it. That's it. So the most common methods used on a set are 2, 3 maybe. Add, obviously, to add elements to a set. Contains, to check whether a particular element is there in that set or not, correct? And well, honestly, these are the most popular methods. Contains and add. Add an element to a set, contains. Now in add, can you go? Add, you have to be careful. It returns a boolean. Can you see that? If the addition is successful or not. When will an addition be unsuccessful? If that element already exists in the set, then you can't add it. So this has value. Add, if it is already existing, it will return a false. Of course, you can always check for whether it is there in the set or not by looking at contains. So let's go to contains and see what it returns. It also returns a boolean. Okay? Whether it is there or not, true or false. Okay? So it returns a boolean. We have all these methods, nice methods. We have remove all, contains all these methods. Okay? Now, I don't know. Can you work on a set by yourself, or do you want me to show an example? Meaning, we can give you an exercise or we can give you an example. Okay, let's do one example on our own. Okay, we'll do one. For all these, please include java.util.star. We know already. Okay, now we'll write one. You can create a set like this. Yeah. So we'll create a set. How do we create a set? Same way like we created a map with generics. So set integer. Set integer. When you have key value, you give a comma. Set integer s is equal to, either you say you want a hash set or you want a tree set or whatever set you want. Let's say tree set, new tree set. Angular bracket, which automatically will determine now you want a set of integers. And let's demonstrate. So s dot add 4, 3, okay, 4. Will this work? Yes. 4 will be converted into integer automatically. This is called in Java auto boxing, packaging. It will be wrapped and converted into integer. From int, it will become integer automatically. I don't have to do anything. So s dot add 7. Okay. Now s dot add 11. S dot add 11. Okay. Done. Now I will check whether a particular element occurs or not. Boolean b, just to check. Boolean b is equal to s dot contains 14, and I will say system.out.println b. Okay, done. Now I will print it. I'll run it. So it should give me a false. Okay. So you can see on the screen the answer comes as false. Okay. This is normally the two operations which are done on sets, add and contains, to check whether it is there or not, add to add it. Very common operations which are done. Okay. Then going back, I will check, let's say 7. So it will return a true. Okay, so it returns a true. Okay, now because it's a tree set, if I print this set, I'll get data in a sorted order. Let's check that out also. Okay, so I'll print the data, I'll print S. Okay, so we are getting true and we are getting data in a sorted order, 4, 7, 11. Okay, because it's a tree set. Okay, that's why we are getting data in a sorted order. Had it done a hash set, we would have got in whatever random order. We won't know what order, right? Okay, now I am going to give you an example which will need the use of a set. Okay, you have to be a little clever, little, not much, but you have to build that. Okay, so let's see whether you can think and do this example. Think a little. Okay, I will we open the question. We'll open the question, analyze it, and we have to finish it in the next 20 minutes. I'll explain it. Open? Okay, let's go to the question. Acha, we opened a question, it is called, it's called program 2. We have opened it. Okay, now, okay, so here is the way we want to do. If you want, read the English, or you can, Ajay applied for number of its digits. Okay, sum of squares of its digits. Acha, there is a small typo. It is, I hope you understand. What is it? How did I get 82 is what? Take every number, square it. Take every digit of a number, square it. So what will happen is, okay, this question will need a little elaboration. 1 squared plus 9 squared is 82. Now 82 will become 8 squared plus 2 squared, 68. 68 will become 6 squared plus 8 squared, which will become 100. 100, if you take each digit and square it, it will become 1. And will it enter that number? Yes, 1. Now, none of the sums have repeated, if you notice. First time the sum came 82, next time the sum came 68, third time the sum came 100, none of them repeated and it went to 100. But suppose you have got 82 again, you should not go doing it, no? Because some number which you already got, if it comes again, then you are going to go into an infinite loop and you are going to do a false. So that is where the set comes in. Okay. Do we have another example? Case 2 or something? Okay, enter number 2 is not good. 2, if you go on doing it, 2 will become what? You square it, it becomes 4. 4, the square becomes, okay, let's try this. I mean, why this will not lead? Okay, let's do this once. So 2, now if you square it, I get 4. 4, if I get the square of this, I get 16. 16, so I have to store all this in a set so that when they are repeating, I don't have to do that. So in my set 2, 4, 16. So before I examine that number, check whether it has come already. If it has come already, don't go, because now you have to say false. You will see what happens. 16 will become 1 plus 36, 37, correct? 37 we will store here, no? 37, okay. Uh, 37 will become 9 plus 49. It will become 58. We will store it here because it has not repeated. We'll continue. So 58, 25 plus 64, 89. It has not come yet. So we'll repeat it and store it. 89 will become 64 plus 81 becomes 145. Will become 145, not come yet, so we'll keep it. So 145 will become 1 plus 16 plus 25 will become 42, has not come yet, so we will keep it. 42 will become 16 plus 4, 20. 20 has not come yet, so I'll 20 has not come yet, so I'll keep 20. Then it becomes 4. 4 has come already. So a number is coming again, which is coming again. So if this number is already there in this set, then it is definitely going to false, because now you are starting another loop. Correct or not? So again you are going to, so if you find as you are doing it, if the number comes, then you are done. It's an infinite loop. You have to write a while true loop. While true, infinite loop. Go on playing with the number again and again. Now you know how to take digits of a number, no? By 10, modulo 10 by 10. So give it a shot. Try this. You have to either say true or false. That's all. Answer is only one word. Let's see how many of you can do it. It's not difficult. You just have to create a set and keep doing that number calculation. If you want, you can write a nice method for that, or you can do it in a loop. But you just write it neatly. Sum of squares of a number. You just have to write that while n greater than 0. Remember, to get the digits in a number. Extract the digits from a number, and then that creates a new number. Check whether that number has already come in the set. If it has come, if it is repeating, then return a false. If it's not repeating, add it to it and proceed. Add to the set and proceed. You have to remember the numbers which have come so far, no? The sums. If that sum comes again, that means surely it is not going to lead anywhere. It is going to again be a loop. As long as you are getting different numbers, you are fine. If you are going to get the same number again after summing, then you are gone. That this will never lead to an answer. It will never come to 1. Please use set. Yeah, another 4 minutes we have to start solving. You just have to write that loop while n greater than 0. Keep dividing and modulo. Modulo extract, that is the digit, square it, keep it in a sum. That sum becomes a number in the next iteration. So there have to be 2 loops, one outer loop which is an infinite loop. You can come out of the infinite loop on 2 conditions. One is if you get 1 as a sum, or you get a number which is already there. One of these 2 conditions will take you out. Now let's look at some of the earlier solutions. First one, okay. Let's see how someone has done. So there is a, okay, let's see. So we'll go through the code. So line 30 says enter a number. So you read a number. He's created a hash set on line 32. Good. That is how you create a hash set. Then there is an infinite loop, while true. That is the correct way of doing it. Because there is only two ways of coming out of this loop. Either you get a 1 or your number repeats. That means it is going to go off false. So while true, then he squares, he doesn't square the number. I think he gets the sum of squares. He's written a nice special function here. This is nice. This is a good idea because modularity. The code becomes modular. Okay, you should always try to factor out code which is in a loop, which is regularly used, because for every number you need the sum of squares. So it's good to factor this out into a nice method. The method has to be marked static, otherwise it cannot be called from main, right? Because static can call only static. Main is static. So this is a very nice thing to do. Public static int square sum of squares int. So what he is doing is he is saying while this is a classic loop to get number of digits. If you have to understand this code, you know. So int n int m equal to 0 while n greater than 0, while it has not reached 0 yet, you say m is equal to m plus, because you have to keep on adding the digits, m plus square of the digits actually, nicely written, n modulo 10, n modulo 10, that will give you the square of the last digit, and n becomes n by 10, so it reduces. So this gives you m, returns m, which is the sum of squares of a particular number. So go up, okay. Now whenever you are given a number, he does the sum of squares of that number, that is k. He checks whether k has come before or not. So if s contains k, then we have found that this number is repeating, so it will never go to 1, and that's a nice code. If s contains k, then you should print out a false and break, because there is nothing more to do. You have to break out of the while loop because there is no point, correct? Then else if k equal to 1, k equal to 1 is very good. You got your answer, sum of squares has come 1. Now it's time to end again. You say true and break, wonderful. Else, it's neither repeating nor it is 1. So you add it to a set and try again and keep doing it again. And so s dot add k, n equal to k. Now k becomes n, rather n is equal to k, because now your entire logic is based on n. Wonderful, very clean, very neat, and almost perfect. I wouldn't say almost perfect, it is perfect. Okay, so very good code. Who is this? Very nice solution, very good. I will say it is perfect because this is how it should happen. Okay, let's look at somebody else's. Who is this? Uday Kant. Uday Kant, okay. Let's see, okay. Make it bigger. Somewhat more bigger. Okay. Okay. He has written the loop inside. It doesn't matter. So enter a number while x is, that means not 0, or while x is true, he remains in the loop, which is okay, which is like writing an infinite loop, while x and n not equal to 1, that is he has not come to 1. Then what does he do? He adds n to 1, okay, to check whether it is repeating or not. Okay, good. That I like the use of x as a variable, because if you see the number repeating, then x will be false and he will come out of the loop, okay, with a false, and he just has to print x in that case. Very good. Now x dot add n, again a loop for doing that stuff with the power of sum of squares, and n is equal to int m, the new n, and every time checking whether it is able to add or not, and it is not equal to 1. Very good. Even this is very good. I like line 40 a lot. This is very nicely written. Who is this? Uday Kant. Okay, good. Your 40 line has made my day. Okay. It's very nicely written. I like that kind of elegance where you say something is there, and if it's written by yourself at this stage, it's simply wonderful. Okay, good. Okay, the rest is okay if x is coming out true, all that is out after the loop. Okay, let's look at one more. Okay, another style, good. Okay, so new hash set while true. Okay, dividing the number by 10, squaring it, setting it to dividing it by 10, then again squaring the second digit. If a here the only thing I will say is there is a small problem. Are you assuming that all the numbers are 2-digit only? The number we give you, or is it okay? If a equal 1, okay, flag equal to true and break. Okay, come down. Now you need a loop there. Okay, there. Okay. So in the beginning you need a loop so that you will get everything out. Here I see you doing A and B and then squaring it and adding it. What if there are 3 digits? S dot add n, add A, that is all okay. Okay. It will work because probably all the, do you understand what is the limitation? It's doing only twice. You have to do that in a loop. Okay. Okay. We will go one more. Hash set, enter a number. This is good. This is the function again. So there is a function called total, which adds the sum of the squares, I guess. Yes. And this I like, the modularity, which I think the first person also had it. Enter a number, next in total, then while set does not contain that, we are good. Set add t, t is equal to total t, and keep doing it. Okay. Now, when will you come out of the set? Okay, this logic is also okay. When you come out of the set, when you have got a repeating number, there you are checking if set contains 1, it has already come, but I would say that you do that inside the while loop. If set contains 1, you break there itself out of the while loop and come out. Rest of it is okay. So set some flag and come out. That thing should go inside because you don't want to continue if you have got a 1. There's no point going forward. You just come out because you are done. Who is this? You know what? Just come out. Don't go on. Okay? Nothing wrong, but it will be like you will wait for a repeating number, then only come out. Okay? Instead, as soon as you get 1, just break out. Okay, we'll go through one more. Okay, we are looking in this last because we have run out of time, but I am liking the approaches. So here is the hash set, reading the number. Okay, while true loop, if n equal to 1, coming out. If s contains n, printing out false. Okay, this is pretty standard, straightforward. Only thing is, instead of writing a function, the person here has created a loop. Okay, n is equal to t. Okay, this is also okay. Okay, similar except no function, but a loop exists. Okay, good. So these are all of them are good, except maybe 1 or 2 cases where some things have been overlooked. Okay, so we'll stop here for today. In the next session, we'll do again one map, one set, and one list. Okay, and also we'll see how to use comparators with lists. But some of you are making good progress. This is all very encouraging stuff.